Define x symbol y to be the absolute value of x minus y for all real numbers x and y. What is the value of? So let's work with this and their definition. So we have 2 minus 3 would be that guy, and this is a 1. So let's do that, and then this would be 1 minus 2 absolute value, and then we'll do the symbol 3 later. So this becomes 1 symbol, that's going to be 1. Okay, and then this will become, I think, 1 symbol 3. And then again, using the definition, this is going to be 1 minus 1, and this will be 1 minus 3. Absolute value, don't forget about the absolute value. So this will be 0, and this is going to be, let's see here, minus, and that'll be 2. So this will just be minus 2. And you can put in the equal signs, but you don't really need to since you only need the answer, which is A. In rhombus ABCD, point P lies on AD so that BP is parallel to AD. AP is 3, PD is 2. What is the area of ABCD? So it's a rhombus, right? So because it's a rhombus, we know that the sides are going to be equal. So for example, AD, that equals AB. Okay, well, I think they told me AP is 3 and PD is 2, so that means AD is 5, so that means AB is 5. So there you go, put a 5 there. And then this is a right angle right in there, so this is basically this triangle is right triangle. So without too much calculation, you all can figure out that BP is 4. 3, 4, 5 is probably the most common Pythagorean relationship in a triangle. Okay, so now we just have to figure out the area. And if you were to just take this segment here and place it over here, right, it would just become a rectangle with the dimensions 5 and 4. So the area would be 5 times 4, which is 20. And that's pretty much it. So D is the answer. How many of the first 10 numbers of the sequence 1, 2, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2, 1, 1, 1 are prime numbers? All right. So a little bit of factoring here. 121, most of you know, is 11 times 11. That one is a bit obvious. But then the other ones are not obvious, right? That one is probably going to take a little bit of figuring out. But this one is 101 times 111. And the next one, 1112, 111, is 1001 times 1111. So as you can see, you can kind of see a pattern there. So pretty much every single number in that kind of sequence will be able to be factored into two numbers. And because all of them can be factored into two numbers, none of them are prime. Because prime numbers cannot be factored, right? 19 cannot be factored into two numbers other than 1 and itself. But as you can see, all of these can. So none of them will be prime numbers, so the answer would be 0. For how many values of the constant k will the polynomial x squared plus kx plus 36 have two distinct integer roots? All right. So we have x squared plus kx plus 36. Now, it's going to have two integer roots if the discriminant is greater than 0. You all know what the discriminant is, right? So this is what we have to work with. In that equation, b squared minus 4ac would be k squared minus 4 times 1 times 36. And that's got to be greater than 0. So this becomes k squared is greater than 144. So let's see here. And that's about as far as I can go there. Now, one thing is for sure that k squared minus 144, this discriminant, if you look at it, right, if you look at it from the quadratic equation, I'll just write it out. It'll be a little bit clearer. Well, minus 144 all over the square root sign over 2a, right? What's under the square root sign has to be an integer. That's the only way you're going to be able to get integer roots. So that basically means that this guy has to be an integer, and it also has to be a perfect square. So I'll just write it as m squared. So that's the sort of the approach here, concentrating on the discriminant and making sure that it's a perfect square. So then we'll just look at this guy here. If you rearrange it a little bit, you get k squared minus m squared is 144. And that means either we have k minus m and k plus m is equal to 144. And we now have to work with this. So let's make a table. We have k minus m, we have k plus m, and then we have k, and then we have m. And we really only care about k. We don't really care about m so much. Okay, so let's see what we can do. And most likely, k plus m is going to be greater than k minus m, so just keep that in mind. So we can have 1 and 44. These are just the combinations, right? 2 and 72, 3 and 48, 4 and 36, 6 and 24, 8 and 18, 9 and 16, 12 and 12. And I think at that point I'll stop because this one doesn't satisfy this guy here. So we're just going to work with these ones. And the algebra is fairly straightforward. All you have to do is just add this and this. The m's will disappear, and then you just have 2k, and 2k will equal, in this case, 145. And if you divide by 2, it'll be whatever that is, 72.5. But that's not an integer. We want integer values of k. Yeah, constant values. So you get integer value for k for this guy. You get 37. This is 20, and this is 15, and this is 13. Yeah. But they don't tell me anywhere that they have to be positive. They could be negative as well. So in addition to these values of 37, 20, 15, and 13, I also can put the negative values. So minus 37, minus 20, minus 15, and minus 13. Those will work also. And yeah, because these ones, for example, this could have been -2 and -72. Yeah, and if you did that, you'd get -37. So if you add up all these guys, you have 8. 8 values, and therefore the answer to this question is B. The point -2, -1, -2 is rotated 270 counterclockwise about the point 3,1. What are the coordinates of the new position? Let's draw a diagram, and let's see what we can do here. So we are starting with -1 and -2, okay? So -1 and -2, so we are starting here. And then they're saying it's rotated about the point 3,1. So 1, 2, 3, and 1. So it's rotated about this point. Okay. All right. And it is rotated 270 degrees counterclockwise. So I've got to first draw a line from there to there. And then I'm going to draw a line that's let me just first extend this axis here. Yeah. Like that. And then I've got to draw a line that's perpendicular. So something like this. Yeah. Okay. So then what we're basically doing is we're taking this point right here and we are rotating it. Kind of look at this line as sort of the line that's going to be rotated, right? So it's being rotated 270 degrees counterclockwise. Okay. So that means it's going all the way around to here. Yeah. Okay, so then if we did that, it will point here. This line will basically swing back to here. And then they want to know, where does it end up? Okay, well, let's see where does it end up. I guess the fastest way to do this is just sort of look at where it was originally from this sort of rotation point. It was 3 down. Right? It was 3 down and 1, 2, 3, 4 to the left. Yeah. 3 down and 4 to the left. So that means the same sort of dimensions will hold true here. This triangle basically will now be this triangle, which essentially will have the same dimensions, 4 and 3. So if it's 3 this way, then that means this coordinate will have an x coordinate of 0, and since this was 1 and it's 4 above, that will have a y coordinate of 5. So that's pretty much how I did it, and just kind of fiddling around with this, and that would give you B. Consider the following 100 sets of 10 elements each. How many of these sets contain exactly 2 multiples of 7? All right, so we're going to have to look for a pattern here. First, let's list the multiples of 7, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. I would just want to get some sort of a pattern. And let's see now. Let's see what if there is any kind of pattern. So we want multiples of 7, right? In each set. So each of these sets, like, 0 to 10, 1 to 10, 11 to 20, 21 to 30, and so on. So let's see what happens. So we got 1, 1. This one has 2. That one, this one has 2. Then we have, let's see here, 1, 1, 2, 1, 2, 1, and then we have 2 in the next one. So let me just write them out. 1, 1, 2, the number of multiples of 7 in each of those sets. And then 1, 2, 1, 2. Okay, let's keep going here. 1, 1, 2, 1, 2, 1, 1. Okay, that sounds very similar. 1, 2, 1, 1. So I'm going to put a little dash there because I think I already got a pattern here. Let's try one more. 1, it was 1, 1, 2, 1, 2, 1, 2. 1, 1, 2, 1, 2, 1. This is not 2. This is actually, you got to extend it to there. I got to be careful here. Okay, I think I got it. So let's keep going here. 1, 1, 2, 1, 2, 1, 2. Okay. 1, 1, 2, 1, 2, 1, 2. Okay, so that's the pattern. Okay, got it. So the pattern is a 1, 1, 2, 1, 2, 1, 2. So it ends there. 1, 1, 2, 1, 2, 1, 2 ends there. 1, 1, 2, 1, 2, 1, 2. Okay, got it. So that means that every time we get to this 70, multiples of 70, this pattern continues. Okay, so basically that's 7 sets, right? From 1 to 70 is 7 sets, and then from 71 to 140 is another 7 sets. And the sets containing, the number of sets that contain 2 multiples of 7 is 3, right? Because this guy, and this guy. So every 7 sets, you have 3 of those. So what are we going up to here? We're going up to all the way to 1,000. Okay, so we go up to 1,000. All right, so that means we're going up another, let's see, 1,000 divided by 70 is about 14 and change, right? So that's another 14 sets. So that's a total of 14 sets, actually. So 14 sets, if 14 of those 7 sets, 14 of 7 sets. So each 7 set has 3. 14 7 sets would have 14 times 3, which is 42. Now remember, 14 times 70 is only 980. So we still got to look at the last 20. Now the last 20 would be 2 sets, and the first of that will have 1 multiple of 7, and the second will have another 1 multiple of 7. So the last 20 don't add to this 42. So it's just 42, and therefore that would be B. Camilla writes down 5 positive integers. The unique mode of these integers is 2 greater than their median, and the median is 2 greater than the arithmetic mean. What is the least possible value for the mode? Okay, so we have a situation where we have a, b, 5 integers, right? But there's a mode in there, so there has to be one value that is at least appearing twice. So I'll just call it d, and I'll just make it appear twice. I'm not really sure, to be honest, how many times it appears, but let's just go with this. Then they say that unique mode is 2 greater than the median. Okay, the median is the middle value, so that's c. So the mode is d, and it's 2 greater than the median. So that means that d is equal to c plus 2. So that's our first equation. And then they tell me that the median is 2 greater than the mean. So the median is c, and the mean is just the average. So that's a plus b plus c plus 2d all over 5. And the median is 2 greater than that, so plus 2. All right, so that's pretty much the setup. Now let's write this as much as we can in terms of one variable, or I don't think we'll be able to get it in one variable, but let's try to see if we can combine it. So a and b, I don't think there's much we can do there, but c, can I do anything with c? I don't think so, but d I can write as c plus 2, like that. So these are my 5 integers. And then this c here, this calculation, that would therefore become a plus b. Since d is c plus 2, I can make that substitution. So c plus 2c plus 4 all over 5. And then don't forget that plus 2. So that's going to be a plus b plus 5c. Or sorry, 3c, I should say. I don't know where I got the 5 from. 3c, and then plus 4 all over 5 plus 2. Okay, let's see. Can I do anything here? This becomes c minus 2, and then I multiply it by 5, and that's going to be a plus b plus 3c plus 4. Crunching out these numbers, we get 5c minus 10, and then if we bring the c over, it'll be 2c minus 14 is equal to a plus b. And I think that's about as far as I can go. Or I can just write 2c is equal to a plus b plus 14, like that. Okay, so we want the least possible value for the mode. So we want the least possible value for d. All right. Okay, well, from that equation, 2c is equal to a plus b plus 14. 2 times c, whatever c is, 2c is even, right? You're multiplying by 2. So that means this has to be even. And we want to minimize, we want the least possible value for the mode, which I have represented as d. So we want the least possible values for c and for a and for b. That's the only way we can get the least possible value for d. So what are the least possible values? They're integers, right? They're positive integers. So the least possible value for a and b, such that a plus b plus 14 is an even number. Let's try 1 and 1. 1 and 1. Oh, but they can't be the same because a and b are different. Okay, how about 1 and 2? That would give me 17. 17 is not even. How about 1 and 3? 1 and 3 would give me 18, and that is even. Okay, that works. So that means that 2c would be 18, and that means c would be equal to 9. And therefore d, according to this guy, would be 11. And I think that is the least possible value for the mode. What is the graph of y to the power of 4 plus 1 equals x to the power of 4 plus 2y squared in the coordinate plane? Y to the power of 4 plus 1 is equal to x to the power of 4 plus 2y squared. Okay, so we have to try our best to figure out what this looks like. Let's rearrange it a little bit. Y to the power of 4 minus 2y squared plus 1, leaving that x to the 4th. Let's make a couple substitutions. Let y squared, let's it equal a, and x squared, let's make it equal b. So therefore, this would become a squared minus 2a plus 1 is equal to b squared. And this factors nicely into a minus 1 all squared is equal to b squared. Now, we have to look at two scenarios for this guy right here. The first scenario is if a is greater than 1, and the second scenario is if a is less than or equal to 1. And let's see what happens. So if a is greater than 1, then that means this equation, this guy up here, basically, we can just take the square root of both sides, and it would just be a minus 1 is equal to b. And that means a minus b is equal to 1. And substituting those back in, it would give you y squared minus x squared is 1. And this is a classic equation of a hyperbola. All right, so we got that. Now we turn our attention to this guy, which is a is less than 1, looking at that equation. If a is less than 1, then that equation, when you take the square root of both sides, becomes 1 minus a is equal to b. Putting these substitutions in, it'll give you 1 is equal to x squared plus y squared. And that is a classic equation of a circle, as most of you know. So circle and a parabola, and therefore the answer is D. The sequence A0, A1, A2 is strictly increasing arithmetic sequence of positive integers such that 2 to the power of A7 is equal to 2 to the power of 27 times A7. What is the minimum possible value of A2? So we have 2 to the power of A7 is equal to 2 to the power of 27 times A7. All right. So let's see what I can do here. 2 to the power of A7 over 2 to the power of 27 is equal to A7, right? So this means that A7 is equal to 2 to the power of A7 minus 27, simple exponent laws. Okay. So we want minimum values of everything. So, and also they have to be positive integers, okay, that's important. So the only way that's going to happen is, the first thing is A7 has to be greater than 27, right? And A7 obviously is a power of 2. Okay, so if we look at powers of 2, we have 2, 4, 8, 16, 32, 64, and so on, right? So what is the minimum power of 2 that is greater than 27? And I think it's this guy right here. Yeah, so I'm going to choose that. So therefore, I'm going to make this 2A7. I'm going to choose 32 minus 27. And that's going to be 32. So does that work? Yeah, 2 to the power of 5 is 32. Okay, so it all works out. Great. Okay, where do I go now? What am I trying to do here, actually? Oh, A2. I have to figure out A2. Okay, so A0, A1, A2, A3, A4, A5, A6, and A7. Okay, so if it's an arithmetic sequence, then this was A, this is A plus D, A plus 2D, and so on, right? And this would be A plus 7D. So A plus 7D is equal to 32. That is what I had concluded up here. Okay, so I want this guy, which is A plus 2D. All right, so how do I do that? I guess I have to sort of, I have only one equation here. So how do I figure out two values with one equation? I guess I just have to concentrate on just min and max, that kind of thing. Okay, so A plus 7D is equal to 32. So if I want the minimum possible A, I'm going to have to try to get the maximum possible D. So let's see here. And of course, they're all positive. So if D, for example, was 4, this would become A plus 28 is 32, which would mean that A is 4. And I think that's the maximum D, because if I made D anything bigger, I would get a negative value for A. So I think this is A equals 4 is about as low as I can go. So plugging that back into here, this would be 4 plus 2 times 4, which is 12. And I think that's it. So that would be B. Regular hexagon A, B, C, D, E, F has a side length of 2. Let G be the midpoint of AB, and let H be the midpoint of DE. What is the perimeter of GCHF? Let's draw a regular hexagon, and let's try to figure this out. So let's label it A, B, C, D, E, F. And then what they are saying is G is the midpoint of AB, so this is G, I guess, right here. And then H is the midpoint of DE, so this is H. And then I guess we're just, what is it? G, C, H, F. Okay, so this guy, right, this shape, they want you to figure out the perimeter of that. Okay, so here we go. It has side length 2, so that means AF is 2, and therefore AG would be 1, since G is the midpoint. So this is pretty much the triangle I'm going to concentrate on, because if this is X, then this will also be X because of the symmetry of this diagram, and the perimeter would basically just be 4X. So as long as I get X, I can figure this out. So this is 1, this is 2, and this is X. And the internal angles of a hexagon, even if you don't know, you can sort of figure it out pretty quickly. Hexagon can be divided into 4 triangles, right? So the internal angles are going to be 4 times 180, since one triangle's internal angles are 180. This is 4 triangles, so 4 times 180. And then we divide by, we're going to have 1, 2, 3, 4, 5, 6 internal angles. So that's, even if you don't remember, that's how I actually do it. So it's 120. So that means that this angle is 120. So put a 120 there. And at this point, I think you just use cosine law. So cosine law on this triangle would be x squared is equal to 2 squared plus 1 squared minus 2 times 1, cos 120. Yeah, so x squared would be 5 minus 4. Cos 120 is negative a half. So this is going to be 7. So x is root 7. So therefore the perimeter is 4 times root 7. And that would mean the answer is D.